Hello friends, welcome to my channel. Let's have a look at problem 930, binary subarrays with sum. In this video, we're going to share a solution based on dictionary and check technique. First, I'll read through the statement to digest the problem requirement, and then we do a detailed analysis, and finally we share the short code. First, the statement. Given a binary array called nums and an integer go, return the number of non-empty subarrays with a sum go. So here we are considering subarrays, which is a contiguous part of the array. So here the subarray or the continuous piece. So this assumption actually is important for the coding part. So this partially determines the way we treat this problem or problems of the same kind. So here are two examples. Example 2 is very special because in the list all the elements are 0 and the goal is also 0. So this problem, it reduces to count the number of different subarrays. So the length is 5, so the different subarrays is 15. You can consider the subarrays of length 1, length 2, and length 5, right? So notice that in this problem we consider non-empty subarrays, right? So this is example 2. In example 1, so the goal is 2. So here the output is 4, and in the explanation it specifies the 4 different subarrays. So with that said, let's also look at the constraints for this problem. So first, the list nums is bounded below by 1 in length and above by 3 times 10 to the power 4. The former tells us that this list is not empty, and the latter gives us the upper bound for the problem size. The second one is that the list is a binary list, and the third one is basically a consistency assumption because the elements are binary, so the total sum is between 0 and the length, right? So with that said, so we are ready to look at the analysis. So the method is now actually a very common method as a dictionary and check. The idea is actually very simple. So we're going to use a dictionary to store the partial sum s and its frequency. The frequency is for counting purpose for sure. The logic is that for partial sum s ending at index I, if s minus the target has appeared k times in the dictionary, then there are k corresponding subarrays ending at index I with sum equals go, right? So we just need to sum the contribution at each index I to get the return. The reasoning actually is simple. So each appearance of s minus target corresponds to an index I0 or equivalently to a prefix sum. Let's call this index I0. So it says that the sum of elements from 0 ending at I0 equals s minus target. As we know from the partial sum that the sum from the beginning ending at index I has sum s. So the subarray starting from I0 plus 1, right, ending at index I has sum that is difference of this 2, that is s minus target, that is nothing but target. Notice that because I0 is strictly less than I, so I0 plus 1 is at most I. In other words, so this subarray contains at least one element, that is the number at index I. So it's not empty. So which is it fulfills the problem requirements. So that's the reasoning. So now, with that said, let's give a walkthrough for example 1 to better understand the details. So the reason we do this walkthrough is that this kind of problem is actually very common and very classic. It's good to have a genuine understanding about the details. So here the nums is given here and the goal is 2. So we first initialize the dictionary to be this one. So we have a key that is 0 and it appears once. So this initialization is to treat the case that for a certain subarray starting from the very beginning and then ending at some index which has some target, right? So the result is a counting variable and s is the running partial sum. For the first element at index 0, that is 1, so s equals 1, right? So s minus go is not in sin, but we need to update the sin to be 0 appears once, that's the initial one, and 1 appears once now. So this is the first step when we look at index 0. So now let's look at the second number at index 1. So s is the previous state of s, that is 1 plus 0 is still 1. So s minus go is still not in sin. We need to update the sin. So now 1 appears twice, right? So next we look at the third number at index 2. So this is 1 again. So s equals the previous state, that is 1, plus the current number, that is also 1. So we get 2. So s minus go is 2 minus 2. It's in sin, right? So we are going to update the counting. So the result equals its previous state plus the frequency of 0. That is 0 plus 1. So we get 1. So we update the dictionary. So 0 appears once, 1 appears twice. Now we have a partial sum 2. It appears once. So next we look at the fourth number at index 3. So this number is 0. So we have s equals the previous state 2 plus 0. That is 2 again. So s minus go, that is 2 minus 2, is in sin. So we update the counting again. That is result equals the previous state plus the frequency of 0. That is 1 plus 1. That is 2. So in this case we have 2 again. So 2 appears twice also. So next we look at the last number at index 4. So this last number is 1. So we get s equals previous state 2 plus 1. That is 3. So we get s minus go, that is 3 minus 2 in sin, right? So we are going to update the result state, that is the previous state plus the frequency of 1. That is 2, the previous state, plus the frequency of 1 is also 2. So we have 2 plus 2, that is 4. So in this case, the sin is 0 appears once, 1 appears twice, 2 appears twice, 3 appears once. So this way we finished the check for each of the indices. So the return is the final state of the result variable, or the counting variable, that is 4. So we return 4. So this is corresponding to example 1. So with that said, so we are ready to write the code. The code actually for now is very simple, right? So first, let's make some preparation. Let's call it step 1, preparation. So for this, I'm going to initialize a result variable for counting, that is 0 initially. Then the dictionary for check, that is 0 appears once. Next, we are going to initialize a partial sum at the very beginning, so to be 0, set to be 0. So next, we are going to do the dict and check, right? So for this, we're going to iterate over the nums. So we do not need the index actually, right? So we implicitly use that. So here we get s incremented by y. And then what we're going to do is to check if s minus go is in sin, right? If so, what we're going to do is to update the result by the frequency of this number, s minus go, right? So no matter what, so as we increment this partial sum, we're going to update the partial sum frequency in sin. For this, we're going to do this. So sin s equals, overall, we want to increment the counting by 1. So it's possible that s didn't appear in sin before. So we're going to use sin and get, right? Get the key, that's s. If not exist, we're going to use 0. Then we plus 1. So this is the dictionary and check. And finally, we return the result. So we return result state. So this forms a solution format for this problem. So now I think we are ready to do a check. So let's check this. Yeah, it passes the first example, which we have went through. So now let's look at generic case. Yeah, it passes all the generic cases. So yeah, with that said, I guess that's about it for this specific problem. Actually, this general line of idea can be used to solve a number of similar questions. So with that said, I guess that's it for this video. Thank you.